So I just wanted to show you what I did here on the bottom of the intake. If you remember, it was like a channel that was in this flange, and it connected the two front cylinders on each side to this like little vacuum nipple on the back of the engine. So the PI heads don't have that, and plus, as you can see, just using the gasket as just an outline of what the port looks like, that channel would have been right where the gasket goes, which would have had some sealing issues. So what I thought of doing is let me just fill all that in with filler. I used about, I don't know, maybe 5 or 6 of these filler rods, 40-43 filler, and I filled that in, and that way when I remember how the manifold is warped anyway, so I'm going to have to fly cut both of these flanges flat again. So after I'm done fly cutting, this will just be one big flat surface, and the gasket will seal nicely on that surface. So I just wanted to show you that, and then I've also kind of prepared. I'm just thinking the remnants of one of our 1/2-inch plates. I'm thinking I could just weld it right about here, weld it here, and then you know, obviously before I do the machining, I would get this welding done, and that way this and this would all be on the same plane, you know, and this would block off, because here's our heater hose. This would block off that port on the head. So that's kind of my plan there. What I've done here is I've just taken my Dremel with an abrasive little cylinder, and you can see kind of the difference between the undeburred side and the deburred side. I just tried to break all these sharp edges and make it just a little bit, I don't know, not perfect, but I'm still working on it. It's not done yet, but you can kind of see I'm just trying to open up the ports so they're not so sharp like that. They don't need to be, and just I've got the plate fitting in nicely, and just trying to make a little bit more progress. Okay, so here it is with the first plate just kind of roughly set in place. I think what I'm going to do is I'm going to line it up. Here's the front. I think I'm going to line it up right about here, and it should be fairly easy to seal all that in with a TIG bead. And the back, I think what I'm going to do, you can see there's that mistake we made. Remember, we went down 1/4 of an inch. Yeah, first we went down 1/2, and then we decided to go down 1/4. So we got to fill that in. But I think I might trim the plate, contour it a little bit somehow, maybe with a grinder or just a hacksaw or something. So that'll get the front and back. The sides are what I'm mostly worried about when trying to seal this in. You can see that will be okay, but here and here I'm going to have to. I'm wondering what I could do. This is basically where I've been trying to get to, and then so now we need a big hole for the supercharger, a small hole for the bypass, and then 1, 2, 3, 4, 5, 6 mounting holes for the top plate that the supercharger bolts to. Okay, I just wanted to show you my fix for the exposed port on the head, the cooling port. I just welded in this block and drilled a hole in it, you know, and then I put on this, welded it, whoops, the side, welded it there too, so that'll be fine. It looks kind of hokey, but it's at the very back of the engine, you know, all it has to do is serve its purpose. So when I mill this, I'll mill this too, so this will all just be one big flat surface, you know, and we'll just keep at it. And I got one more thing to show you. So I went and pulled the harmonic balancer off the donor engine, the 04 Grand Marquis engine, and I just used the impact wrench. I have a electric impact, and zapped the nut off, and then used the puller. and pulled it off. And I was browsing around just for a pulley that I could use, and I ended up finding this guy. This guy is harmonic balancer pulley from a Chevy 4.3 V6 or 350 5.7 liter, like panel, not a panel van, but I think they're called express vans. Here's the part number. I guess that'd just be easier to show you just the part number. AC, Delco, and GM look to be the same number. And this is, I think, 7.8 inches. I'll measure it precisely, but I believe it's 7.8. And I just was thinking maybe I'll get lucky, and sure enough, it kind of fits right in there, and it's, I'm thinking, even though those 3 holes are for pulling it, there's still threads on there, and I can, and geez, the holes even line up, so my plan is to put this in a lathe, grab onto it in a 5C collet on a lathe here, and then I'll go in with a boring bar or a facing tool, and I'll just face off, just touch it off. That way I know it's perfectly perpendicular to the crankshaft, and because I know that this is a precision ground diameter from the Ford factory. Okay, so I'll know that this face is perfectly flat, and then I'll go in here, and I'm gonna have to put it in a mill, and here's the bolt. I'm gonna put it in a mill and bore out to clear our washer. It doesn't have to be that much bigger, and plus that'll get rid of this little protrusion there, which I really don't want that. I know what it's for on the GM engine, but in our instance, it's not going to serve that purpose. And then, even though the holes aren't perfect, I think I have 2 options. There is a little bit of slop in here, left to right slot. Here, I'll put the camera right on the bench, so it's not crazy. I could even like wrap that with electrical tape, and maybe that would be enough. I mean, if it's not exactly perfect, the belt tensioner will eat that up. Or if I want to be perfect, what I could do is put it in a mill. I could put it in a mill table and just clamp it here and clamp it here, and then I would go in with an edge finder, and I would edge find in my Y, and then I would edge find in my X. Then I would move over half the distance of the edge finder, and then I can measure this just with a pair of calipers, and then move over half that distance, and I would be dead nuts in the center, and repeat that process for this axis, and I know I'd be exactly in the center, okay? And then what I would do is I would re-drill the holes based off XY coordinates that I could get from this bolt circle. I would have to measure this bolt circle. And then I could get, all right, it's this far up, and then it's this far down, and this far over, and this far over. Obviously they'd be mirror images of each other. And I would just duplicate this bolt pattern in this pulley, and that'd be about as close as I could ever get it. Without some sort of piloting feature. And like I said, this was $32. So for $30, I mean, come on, let's at least try it. So. Like I said, if it's not perfect, I think the tensioner would eat that up. It shouldn't really matter. And plus, I highly doubt that this is perfect. This is probably just stamped out of a blank. So it's good enough on a GM. Why can't we use it? So anyway, those are 2 things I wanted to show you. And then, yeah, when I'm done with that slight machining, I'll show it to you too, and we can continue with our next steps. And just one more thing I wanted to discuss. This balancer on the 4.6 liter is neutral balance, which means it would be just like balanced as if you were balancing your car tire. You want completely even weight distribution around its circle. So there is no, if your wheels are off balance when going down the highway, the car shakes. Similarly, the same thing would happen if this was out of balance. So this is a neutral balance. So I didn't want to do something like maybe welding. I could weld something, but when I'm melting that metal and adding filler, it could I mean, I don't know if that would affect it terribly, but it would make it out of balance if I were to ever fabricate something that's not neutral, you know. So that's why I kind of went with this, because this is, you know, this is a symmetric part. Everything is equal everywhere, you know. So it also is neutral balance. So I wanted and that would be as opposed to this. This is a balancer off of a 96 through 01. So this is off of 2000 Ford Explorer 302 5-liter, and this is, I believe it's a 28-ounce imbalance. So you can see that there's nothing here, but then there's this big honking weight on there, you know. So, and you can see where they drilled material to make this exactly, I think, 28 ounce, you know. So this is an out of balance pulley, or not pulley, but balancer, and you can see how it'll find center. And the same thing would be on like a FE style engine. Well, actually, it's only the 428. I think it's only the 428. I think the 407 as well. Those are externally balanced, but instead of the balancer being out of balance, the flywheel has a big weight in it. And that way, when you bolt that on, remember a flywheel only goes on one way. So that's so they can know where to put the weight, kind of a thing, or where to locate the weight. I believe the 428 Cobra Jet has an out of balance, a balancer like this with a weight on it. Oh, wait, no, not the Cobra Jet. The Cobra Jet, the Super Cobra Jet, I think it's called. Because I have a Cobra Jet and it had a neutral balance. Yeah, there's another one. I think it's called the Super, something like that. Anyway, just rambling. I'll probably edit that part out. Maybe I won't. I don't know. All right, so I got that little bit of machining done on the balancer, like I told you. So I did exactly what I said. This turned out to be a 1 7/8 diameter, 1.875. So I used, like I said, a 5C bored collet that was bored out to that diameter. Held it in a lathe just like this, and I took a boring bar with the small nose radius insert on it, and I just faced off. You can see how nice that turned out. And so now I know that this surface is flat and perpendicular, so it's nice and true. And then what I did is I took a metric tap. This is these threads, just because they were kind of rusty, are M8 by 1.25. So then I grabbed some socket head cap screws and a washer. So now we can at least mock up the pulley, which I also did a little bit of machining on. So like I told you, I knocked off that little piloting feature, and the end mill, I kind of got a little lazy. I ended up, the end mill I found was only, I think it was 1.5 inches, and the washer is about 1 5/8. So I just put it in a kind of just like this, and then I put a nut on the bolt, tightened it down, and then grabbed this in a collet and just turned the OD of the washer. Well, I guess if I just put RTV, I think oil can leak through here, but there's still plenty of you know, it's not that much smaller. So yeah, I didn't really machine it too much smaller, so I think we're all right. You know, it should be fine. So that's kind of what I wanted to show you. So now what I'm thinking of next is I didn't precision machine those 3 bolts like I was saying before, but the holes do, well, let's see if I can get one of the screws started. Yeah, that one went in. Whoops, threw it right in there, huh? That was a good thing we got another one. Yeah, the bolts are going in. So the bolts are going right in there. So I'm thinking, let's see. I mean, yep. Yeah, so I tightened down the 3 bolts. A little bit too long, but maybe just put another washer, or maybe a lock washer or something. But it fits nice and flush on there, and with the 3 bolts in, the bolt pattern is a little bit smaller than this. Plus, I think these are meant for 3/8 bolts, and these are, well, 8mm, which is pretty darn close to 5/16. So that kind of helped center the pulley. And here's our washer. Fits right in there, hardly any play, and then there we are. There's a modified 4.6 balancer with a GM Supercharger pulley. Looks good. So I want to show you one more thing. So I also got this plate. I started just gently massaging it to get it to work, and I remember I was telling you about how I'm going to get down in there, and I thought, as opposed to trying to get in there with a TIG torch, why don't I just machine some relief cuts in it, and then I can, I can maybe just put a little piece of filler metal, like even like this little strip, just kind of get that in there, and then I can even use that as filler as well as a filler rod, and kind of just fill this gap in. I'm thinking it ain't gonna look pretty, but it should be fine. And then I did still have to trim it. Well, actually, up here is fine, and then here's all right. So I think it's pretty much almost there, but I might do a little bit more modifications to it. So I think the next step is let's bolt that up to the test engine. So we got the new balancer mounted up, no issues. I had to run downstairs in my random nut and bolt pile, and I got some lock washers because it was just rubbing on the timing cover. But now it spins over nice, no interference. So there it is on the, actually pretty good spacing actually. This tensioner, I'm gonna have to have it probably, put the tensioner here, kind of like that Make Cool Stuff guy did, and tuck that belt in so it will go, not hit this. But yeah, I think that's good. But one tiny snag, we got to trim our little block a little bit so our holes line back up. So let me go do that just with a hacksaw, and then we will plop the supercharger on. All right, fixed one problem and found another. So I got just 4 bolts, one in each corner. And then I've got both plates and the supercharger, but I've got this just a 6-foot level just clamped, so I know what plane the belt needs to be in. And as you can see, we've got some interference here. The supercharger is hitting the alternator, and it's preventing me from getting that additional, I don't know, ½ inch or so. So, man, that's all right. We'll fix it. It's just, I think the next thing I should do before we go any further is verify. I'm going to open the hood on the car and verify we have this room. We have a good 2.5 inches of clear space in front of the engine before I go any further. All right, so we're under the hood. Looks like we'll be okay. There's plenty of room, a thumb's length. We got about a thumb's length of room. Definitely got room down by the balancer, no problem. About where the supercharger will be. We shouldn't have any problem either. I wonder how we'll do with hood though, hard to tell. Hard to tell. So what I'm doing now is just to establish the plane of the hood, I've laid the level across the fenders. So basically either way, whether we run 2 belts or 1 belt, the height of the pulley is still going to be the same. It's just either going to be here or here. So kind of what I did is I'm just thinking, all right, if I just put the Sharpie rested on the top of the alternator, it's about a Sharpie's length to the top of the pulley. So if we go on the car, so what I just did is I just put 2 2x4s. 2 2x4s, we're I don't know, just to get us in the, because the hood has an arch to it, so laying it on the fenders isn't really realistic, so what I've got here is an old 2x6 resting on the radiator rigidly, and it's resting on the crank pulley rigidly. And then I just took some shims. I got 2 2x4s and some paint sticks and a piece of 1/4 inch, whatever that is, subflooring. And we're we're right about there, you know, we're right about there. And I just tried closing the hood, and it does clear. It does clear. So, and that's with the block spaced out. You know, that's pretty much where a pulley would be. Pretty right where this block is where a pulley would be, and the hood closes. So I think we'll be okay. So let's go back in the garage and do some more thinking. And since there's no belt on the donor engine, I just wanted to take note of the belt routing on this car. So I'm thinking I'm going to be putting the tensioner right about here. So we got access to that bolt and that bolt. This one goes right into the block. That one goes right into the it goes right into the head, which are both rigid. So I'm thinking we could make something. We could make a block. We can make a block to mount a tensioner to. So we just have to make note that we don't want to go below. You know, we don't want to go below the water pump, but we'll visit that later. But just you know, to keep that in mind. All right, back on the test engine. I'm just thinking we're probably going to be running a slightly smaller pulley, so that would help us for hood clearance. But also, remember, we're going to have gaskets, so we're going to have that gasket between this plate, and then a gasket here. So we're probably going to go up maybe an 1/8 inch, maybe 3/16. So I don't know. It's just, if it hits, it hits. I mean, but I think we'll be all right. 75% sure we'll be okay. So now that we know we got room and everything, let's try and maybe tackle this a little bit more. And I'm thinking, why don't I just mill this junk off, you know? Yeah, I mean, we got to go forward. And so you can see we're also battling this alternator stud as well. I mean, that's got full system voltage coming out of it. So I'm thinking we're going to have to machine some clearance, definitely. But let me think about this a little bit more. Maybe there's something else I can do. So we got to move forward. That's about a 1/2 inch. It's about a 1/2 inch, 9/16 ish. So yes, I could just machine go in there with an end mill and just machine starting here and just slice it. You know, slice that off. I would want to machine from that bottom face up to this rib and maybe a little bit of this rib, and just go in there and just keep shaving it off, and then we'd be able to go forward. You know, this is over an inch. This is a little bit more than an inch, so that would get us the room. And I hate to have to pull the supercharger every time we kind of want to change the alternator, but maybe we wouldn't have to. Maybe we wouldn't have to. We could just remove the 2 mounting bolts. If we ever had to change the alternator, you could just remove the 2 mounting bolts and remove our strap. We'll probably just have a strap from here to here. And then just slide the alternator forward, undo the wiring, and then, you know, hook the wiring up first and then bolt it to the engine. That would work. That would be all right. You know, it'd be a little bit hokey, but I guess it'd be doable. It wouldn't be that bad. So why don't I do that? Why don't I disassemble this front snout? I'll mask it off nice so no chips get in there because the gear set's in there, you know. And then let me go do that machining real quick. And then we can focus on where we're going to put the holes in this plate. So I'll be right back. All right, so I just got back from doing a little bit of machining, and I stopped because I got a little nervous about machining through the case, which I think I'm going to have to do. I think I'm going to have to do that. Remember, the gears are in here. They're not really in here. So if I machine through this and just weld a plate on, I think we'll be all right. I think we'll be fine. But I'm just trying to show about the top of that Sharpie line. Whoops, about the top of that Sharpie line is where we got to go. Kind of maybe flush with this face and just machine that way to a depth of this depth. We should be all right. So let me disassemble it again and kind of peek inside this and see what would be in there that we might disturb. Okay, so here it is off the motor. Oh, sorry, off the supercharger, and you can see there's our mark. So how far over do we have to go? We got to go. I'd like to just cut clear across. We don't necessarily have to go over that far. But if we did, basically all this, we'd be cutting this rib off, this rib off. I don't know if that would structurally weaken it enough or not, but I mean, there's nothing in there that would you know, we would just be, we'd be breaking through right about here, you know, and this. So this would just be an open cavity. We'd be breaking through into that. But there's nothing back there, you know. Yeah, we'd be losing some oil capacity, though. We would be losing a little bit of oil capacity. Let me keep thinking. All right, we're back from the machine shop again. I've got the pulley on the same plane as the crank, and I've got the machining. You can see we had to machine out, and there's the gears in there. You can see them, but that's okay. Well, my plan is I'm just going to take a piece of 1-inch angle iron, but out of aluminum, obviously, and it'll just be welded in there. And maybe I'm a little bit nervous that I had to machine through these reinforcement ribs, but the ones on top are still there. But yeah, I machined through. But I just wanted that way it doesn't really matter. You know, I can get this nice and, you know, centered this way on the intake manifold. The pulley, I don't care if it's centered, but the intake I want centered on the plate. And that way I machined. I'll just flip it up and show you. So you can see I just machined just a straight slot in there. And gonna have to replace the bearings, which I probably should have done, which I probably should do anyway. So I got obviously some chips got in there, but just for mocking it up, that's fine. So I think I forgot to mention that the reason I just decided to go with a second pulley basically is simply just for clearance, to clear the back of the engine. With that elbow in place, I would have had to cut up the wiper tray to a point where the wiper motor isn't. That's what that bump out is for. If I remember in the video of me on the car, that bump out in the firewall, right where this injector is, there was a bump out of the wiper tray. That's where the wiper motor is. So I can't really relocate that. And I'm thinking that and plus it was so easy to get the supercharger pulley on there, and now basically it's just the tensioner. So the tensioner / idler. I mean, if we did one pulley, we would have had to do an idler. But if we do, you know, sorry, one belt, we would have had to do an idler. 2 belts, we have to do a tensioner. So I guess now that we've got this figured out and looks like it's going to work fine, we can move on to the tensioner, which I really don't think that's going to be big. We can use these 2 screws and just make a block, and it should bolt right on there. Okay, so that's kind of my justification for running 2 belts. Plus, the Pontiac I took this off of had its own dedicated supercharger, crank pulley, tensioner, and belt. Plus, I believe this is also installed on, I think, like Ford Thunderbirds, the M90. That also has a dedicated supercharger belt. So I kind of wanted to just follow what the OEMs did. You know, I figure if the car that this came out of had its own belt, let me just do my own belt too. There's probably a reason for it. Maybe it's just the load on the belt itself. I don't know. That's a lot of pulleys for one belt to be working. I don't know, but I figure that way I'm just kind of copying what was done on the Grand Prix, and a Thunderbird. So I'm just using this little piece of metal as a straight edge. And what I'm trying to do is basically, what I'm finding is you can see that the edge of the frontmost sealing surface of the supercharger. See that there's the big boost hole, and then we have the sealing surface, and then this edge. So the front edge of the sealing surface is about an 1/8 inch back at the frontmost of this plate. So I'll base my measurements off that. Now that I know, let's take the plate downstairs and lay it out. All right, so I'm just laying out where the main boost hole is going to go. So I've measured its length with the calipers, and this hole is 4.161 inches long. All right, and I know that from this edge I want to go back an 1/8 inch. So we're going to add on. So to find where this line goes, where the rearmost edge of the hole goes, we're going to take the hole length plus the 1/8 inch 0.125 plus 0.543, which is this thickness. All right, and that gave us 4.829. So from this edge, this line is 4.829. Then what I did is I basically just said, okay, I know I want to go an 1/8 inch plus this distance. So that's where I drew this line, you know. So now I know, all right, this is where I'm going to put the hole front to back, and then side to side, this hole right here is 3.938. So it's 3.938 wide, but I know that my plate, I did 6 inches exactly first, but then this was 6 inches, the pocket and the manifolds, and I machined it down a little bit. So 5.992 is pretty darn close to 6 inches. And then basically I subtracted the width of the hole from that, and that got me 2.054. Divide that by 2, and that's 1.027. So from the edge here, it's got to be 1.027, and from the edge here, it's got to be 1.027. So basically, we're going to take an end mill, and we're going to mill out this rectangle square, and this will just be a big open hole. So now we're going to let's lay out this. We'll lay that out. That's going to be somewhere right about here. Okay, so that'll work out fine. And then what we'll do is we'll probably put maybe a tapped hole here, maybe a tapped hole here, maybe a tapped hole here. Same thing. That'll be 6 holes. So we're just gonna put 6 holes in, and when I do that, I'm going to have to be careful to copy that pattern on the upper plate. Yeah, so here's my 1 inch by 1 inch aluminum angle, but essentially we're just going to do that, you know, and that'll seal everything back up. Should be just fine. We'll take that in and seal it back up, and we'll be good. So I've determined that the center of the hole needs to be right at the intersection of this cross. And the way I figured that out is I measured from this edge to this edge, so just like that. And that was 2.516. Then I measured the diameter of this hole and divided that by 2, so that's 0.7625. And then I added those two numbers together to get 3.279. So it's 3.279 from this edge to the center of the hole. So then I transferred that from this edge to here, and then I just took my 5.992, divided that by 2, and drew that line. So basically I'm going to drill a hole right there, and that'll give me my big hole and my bypass hole. All right, I'm just doing some calculating, and I think I've got where the 3 holes are going to go. Here, 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 and 3 more. Here, here, and here. So it's not going to be symmetric, but just because where the runners are, that's kind of where we're going to put them. So to make the 6 holes, we're basically going to edge find this edge, move over half the distance of the edge finder, then move over 2.1 inches, as you can see, and that's where the frontmost 2 holes will be. And we're gonna go, and then we're gonna edge find this edge, and we're gonna move up 0.5135, drill the hole. Then we're gonna move up an additional, well, not an additional, but we're gonna move a total of 5.4785. Drill that hole. Then we're gonna move over 6 3/8, drill that hole, come back down to 5.135, but instead this is going to be 4 3/4. Then we'll go over 11 1/4, drill it. Then we'll go total of 5.4785, but from this edge it'll be 9.5. So this is basically our master sheet. I should transfer this to a CAD file or something, but this is basically the master sheet, and we're going to need to transfer those 6 holes to the top plate. But this is the drawing, and it's captured on video for all time in case I lose it. So that's what we're gonna do.